Yeah, very good morning to one and all gather over here. So today we are going to see the case study on circular waveguides. First of all, what is circular waveguide? Regarding about this, we want to know the definition of circular waveguide. Why we are going to know the case study of circular waveguides. So this thing will be seen in this chapter. So let us start with first slide. So let me see this diagram. So if you are seeing this diagram, so what is the difference between circular waveguide and rectangular waveguide? We can easily identify. So here rectangular waveguide diagram is presented in this slide, same as it is circular waveguide diagram is also presented. So if we seeing this diagram, rectangular waveguide will be considered and its shape is in rectangular side, rectangular design, same as it is via circular waveguide shape is also same as it is in circular design. So here the mu comma epsilon, that both values are presented in both rectangular and circular. So mu comes under the category of magnetic transverse magnetic waves, and epsilon comes transverse electric waves. So this is the design structure of circular waveguides. So let me move to the next slide. So in the next slide, what is circular waveguide? What is the operation of circular waveguide, and what are all the advantages of circular waveguide? Let us be see in this slide. So this is the circular waveguide. Advantages and operations. The circular waveguides are easier to manufacture than rectangular waveguide and are easier to join. The TM01 mode is the transverse magnetic, 01 is a boundary condition mode, or rotationally symmetrical, and hence the rotation of polarization can be overcome. So T is nothing, transverse electric waveguide. So in this condition TE01 mode in circular waveguide is used for long distance transmission. So these are all the important advantages of this circular waveguide is used for long distance communication. Then magnetic in circular waveguide, magnetic transmission performs rotationally symmetrical to the progress. So next we move to next slide. So next slide, what is mentioned in circular waveguides, how transverse electric and transverse magnetic modes will performing. Here the figure shows a cylindrical waveguide which is simply a hollow tube with circular cross section of radius A and extending along the Z direction. There are two set of modes. One is transverse electric and another one is transverse magnetic mode, which can be propagated in a cylindrical waveguide. So here the diagram represents in cylindrical structure. So here in the cylindrical structure we can easily identify which part is comes under the category of transmission electric and which part is comes under the category of transverse magnetic. So we move to next slide. In this next slide, transverse electric and transverse magnetic mode, how the field analysis will be generated. So according to the boundary condition of Maxwell's equation, here few derivations are mentioned for TE waves and TM waves. So TE waves, left side the derivation it is given, that is called as, it starts from 1 by rho dou E by dou pi plus or minus j beta. E is comes under the Maxwell category, that's j omega mu h minus j omega mu h is the condition comes under transverse electric condition. Here j instead of omega we are going to replacing negative imaginary part. So here real part only included, j omega epsilon e rho. This is the condition of transverse electric and transverse magnetic mode to find out the field analysis condition. So here according to these condition, the rho and pi components can be expressed in terms of Ez and Hz. So here few conditions it is given, E rho, E pi, H rho, H pi. E is your transverse electromagnetic phase condition and H is the transverse magnetic phase condition. So these are all the few applications of circular waveguides. So here the circular waveguides are rotating joints in radars to connect the horn antenna to feed a upper lobe or lower lobe or middle lobe with the paraboloid reflector, which must rotate for tracking. So this tracking will be identified for transmission and band communication like short distance and medium distance. The gigahertz will be 1 gigahertz to 10 gigahertz. So these are all the conditions of circular waveguide applications. So upcoming session we will see the circular waveguides magnetic intensity and progressing of operations. Thank you.